So as I said, we're going to do a little bit different. This one, we're going to use appropriate identity to simplify each expression, and we're not going to use a calculator. So normally we're given like cosine of 255 and we break it up. This time, if you notice, these are already broken up into our identities, and we actually are going to stick them back together. So we have cosine, cosine, sine, sine, which tells me I am dealing originally with a cosine situation. So this would be cosine of 34. That's going to be my alpha because it comes first. And if you notice, this is plus. If this is plus in here, then it has to be a minus originally, minus 13. Okay? So if I had cosine of 34 minus 13, and I was using this identity, it would look like this written out. Then if we simplify this further, we'd get cosine of 21 degrees. So that's simplified using the identities in reverse. Okay? Same with this one. Cosine 3y, cosine y. My printer had some issues apparently. Minus sine 3y, sine y. Again, this is dealing with the cosine because it goes cosine, cosine, sine, sine. So this would be cosine 3y. If this is minus, then it is going to be a plus because this tells me they're opposite. So plus y. So this is going to be cosine of 4y. Okay? Nothing too tricky there. On this one we have sine, cosine, cosine, sine. So sine, cosine, cosine, sine is our sine. So sine of 2. Okay, if you notice this is plus minus, so it means it's going to be the same. So if this is minus, this is going to be minus 7. So then we'd have sine of negative 5. Okay. You can leave it like that, or if you notice the even and odds right here, sine of a negative angle is negative sine theta. So I leave mine like that, or you could write it as negative sine of 5. Okay. Last one, tangent. So tangent, again we have our alpha, beta, so tangent, pi thirds, okay, plus minus, plus minus. So this is minus, it's going to stay minus. If you notice this one was plus, opposite, so it's still minus. Okay, pi fifths. So then if we get a common denominator, that'd be tangent of 5 pi 15ths minus 3 pi 15ths would give us tangent of 2 pi 15ths. Okay, nothing tricky here, hopefully. Those ones should be nice. And then the last ones I want to look at are going to be find the exact value given the following information. Okay, these are a little bit different because instead of using unit circle or anything like that, what we do is we have two angles, both in quadrant 1. Okay, so I'm just going to put angle U in quadrant 1 and angle V in quadrant 1. And I don't know what they look like. I just know they're both in quadrant 1. And I know angle U in quadrant 1 is, the sine is 4/5. And we know sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so 5, 4, we know is a Pythagorean triple. Pythagorean, yeah, that's the right word. And 3. Okay, we know V is in quadrant 1, and angle V, sorry, that's a 90, is cosine. So cosine is adjacent over hypotenuse. Again, a Pythagorean triple. And that makes that 5. Okay, so we're going to do cosine. So cosine, which is not showing up. So cosine is cosine alpha cosine beta plus or minus plus sine alpha sine beta. Okay, so this is like my alpha beta. Not that that matters, but sometimes it's nice to have a match. So I need cosine of u. So cosine of u is 3/5, right? Adjacent over hypotenuse times, and now I need cosine of v. So cosine of v is right here, 12/13. Okay, this is plus, meaning that I will do minus. And then I need sine of u, or alpha. Sine of alpha is 4/5. And then I need sine of v, which is 5/13. Okay, so if we multiply this, we get 36 over, what is that, 65? Minus 20 over 65. That's going to give us 16 over 65. Okay, which doesn't simplify. So the exact value of cosine of v plus u, or u plus v, with this given information in quadrant 1 is 16 over 65. Okay, so still using these, so this is still my u and v. We're going to do it tangent. Okay, so if I do tangent u minus v, so first thing I need is tangent of alpha. So tangent is 4/3 minus, okay, tangent, again minus because this is going to be the same, tangent of beta, or v, that is going to be 5/12 divided by 1 plus, because it's opposite, 4/3 times 5/12. Okay, let's simplify this a little bit. We could do a few different things. I'm actually just going to put these together because that's fairly easy. That's 3 times, just times it by 4/4. So that would be 16/12 minus 5/12. So I'd get 11/12 over 1 plus, let's see, that's 1 plus 20 over 36. So that's 36 over 36. Let's see. So that's what? 1 plus 10/18. 1 plus 5/9. So that would be 14/9. Okay, because that would be 9/9 plus 5/9, so 14/9. However you want to deal with this. Okay, this one's actually not too bad, so that would be 11/12 divided by 14/9. 11/12 times 9/14. So I'd get 99 over 168, which should reduce, I think, 33 over 56, if I'm not wrong. Okay. So that should be our answer on that one. Honestly, tangents shouldn't be scary. They're just a little bit more intense because you got lots of fractions. Yeah. You could have tried to clear these fractions, 36, by timesing everything by 36, and that would have simplified it down. This wasn't too bad to deal with, so I just went ahead and simplified and added common denominators and whatnot. Okay? Last one, sine, which Yep. Yeah, you just look at your paper. Okay. So this one we would have, okay, so this is sine, so we need sine of our first one, so 4/5, and then we need cosine, so 12/13, minus, so it's going to remain minus, cosine, so 3/5, and sine, 5/13. Okay, so we'd get over 65, brain just went blank, 48 minus 15, so 33 over 65. Man, seriously, my brain is just like died on me just now. It's a good thing it's the last one. And yeah, we'll leave it like that, unless I totally goofed. You guys check the math on that one. That one's for you to do. Anyway, that's everything with this unit. I know it was quite a bit. Guys, on these videos, skip through them. See what you need to look at. If you don't need to look at it, don't worry about it. You know, you could do it. You got it. You guys are good. Okay, have a great day.